Hello everyone. In this model, we are going to delve into the critical concepts of sampling and measurement in econometrics. These are fundamental to how we gather and interpret data in economic research. We will explore how we select subsets of a population and how we assign values to economic variables. A key focus will be on ensuring our measurements are both reliable and valid. Let's start with sampling. In most cases, it is impossible or impractical to collect data from every single member of a population. Sampling involves selecting a subset of the population to represent the whole. This allows us to make generalizations about the entire population without having to survey or study everyone. Sampling is widely used in surveys, experiments, and various economic studies. Sampling is crucial for several reasons. First, it significantly reduces both the cost and time involved in data collection. Imagine trying to survey every single household in a country. It would be incredibly expensive and time consuming. Second, it allows us to focus on resources for specific target groups. For example, if we are studying the impact of a new policy on small businesses, we can focus our sampling efforts on that particular group. Lastly, and most importantly, sampling enables statistical inference. By carefully selecting a representative sample, we can draw conclusions and make generalizations about the larger population with a certain degree of confidence. There are two main categories of sampling methods: probability sampling and non-probability sampling. Probability sampling methods are characterized by the fact that every member of the population has a known non-zero chance of being selected for the sample. This method allows us to make statistically valid inferences about the population. Examples include simple random sampling, stratified sampling, and systematic sampling. On the other hand, non-probability sampling methods do not guarantee that every member of the population has a known chance of selection. This makes it difficult to generalize findings to the broader population. Examples of this type include convenience sampling and snowball sampling. While non-probability sampling can be useful for exploratory research, it is generally less rigorous than probability sampling for inferential purposes. Let's explore some common sampling techniques. For instance, in simple random sampling, every member of the population has an equal chance of being selected. Think of drawing names out of a hat. In stratified sampling, the population is divided into subgroups or strata, and then a random sample is drawn from each stratum. These strata could be like income levels or education. This method ensures representation from all subgroups. In systematic sampling, members are selected from the population at a regular interval. For instance, every 10th person on a list is selected. In convenience sampling, participants are selected based on their availability or ease of access. This is often used in preliminary research but has limitations when it comes to generalizability. It is worth highlighting the key difference between stratified and simple random sampling. Stratified sampling offers the advantage of ensuring representation from all relevant subgroups within the population. This is particularly important when we want to analyze differences between subgroups. Simple random sampling, while being unbiased, may not always capture smaller or less prevalent groups adequately. Determining the appropriate sample size is crucial. A larger sample generally leads to lower sampling error and more precise estimates. However, there is a trade-off. Larger samples are more costly and time-consuming to collect. Conversely, a sample that is too small may not be representative and can lead to unreliable results. The ideal sample size depends on several factors, including the variability within the population and the desired level of confidence in our results. Now let's shift our focus to measurement. Measurement is the process of assigning numbers or labels to characteristics or attributes of the unit we are studying. The process connects abstract concepts like economic growth or consumer confidence to the data we collect. Effective measurement is essential for quantifying and analyzing economic phenomena. In economics, we often deal with abstract concepts that aren't directly measurable. Operationalization is the process of defining how these concepts will be measured in practice. This method involves translating a theoretical construct into a measurable variable. For instance, if we are studying poverty, we need to operationalize it by defining specific measures, such as income below a certain threshold or access to basic necessities. In this way, we are able to turn the abstract concept into numerical values. Another important distinction that we need to make when it comes to measurement is reliability and validity. Reliability refers to the consistency of our measurements. A reliable measurement will produce similar results if repeated under the same conditions. Think of a scale that gives you the same weight every time you step on it. That is a reliable scale. Validity, on the other hand, refers to the accuracy of our measurements. A valid measurement truly captures the concept we intend to measure. A scale is valid if it is accurately reflecting your actual weight. Both reliability and validity are essential for meaningful results. Reliable but invalid measurements are useless, and valid but unreliable measurements are inconsistent and untrustworthy. This module covered essential concepts of sampling and measurement, which are core components of rigorous economic research and analysis. The next module will cover basics of statistical relationships.